All right, in our last lesson, we talked about how to count using the fundamental counting principle and also permutations. Remember, permutations are when order matters. Today we're going to talk about how to count using combinations. So a little different. The only difference really is that when you're using combinations, the order doesn't matter. So if I have the same three letters, for example, A, B, C, and C, B, A, those are the same. So we don't want to count that twice. So there's a big difference between combinations and permutations. Formula is very similar. The only difference is we're adding an R factorial there. Again, there's a key on your calculator that'll help you out with this. Okay. Standard deck of 52 playing cards has 4 suits with 13 different cards in each suit as shown. And I'm going to flip back to this so you can see it because I know a lot of you might not be familiar with cards. So this is kind of the makeup of a deck of cards. And you have that sheet just so you can kind of see those and refer back to it because we'll do a lot of questions with this. But there's 4 suits. We have spades, clubs, diamonds, and hearts. Diamonds and hearts are red. Clubs and spades are black. Starting with ace, counting all the way up to 10, and then jack, queen, king are your face cards. So we're going to use that quite a bit when we're doing these problems. We'll come back to that other table in a second. So we're going to use that here, and we're going to count. Okay, so pretty simple. If the order in which the cards are dealt is not important, how many different 5-card hands are possible? Well, if I have 52 cards, and I'm choosing 5 cards, the order doesn't matter here because if I have 2 5s and a 4 and a 10 and a jack, it doesn't matter which ones I got first, I still always have that same hand. So when I do this, I'm going to use the formula 52 factorial divided by 52 minus 5 factorial times 5 factorial. And I grew up learning how to simplify this by hand, so 52 times 51 times 50 times 49 times 48 times 47 factorial over 47 factorial when I simplify that. And then I'm going to do 5 times 4 times 3 times 2 times 1 for my 5 factorial. The reason I was taught to do it this way is because it's really fast to cancel. So 47 factorial cancels with 47 factorial. Pretty simple here. 5 goes into 50 10 times. 2 goes into 10 5 times. Let's see, 4 goes into 48 12 times. And I can divide 51 by 3, or I could divide 12 by 3 even to get 4. So I'm really doing 52 times 51 times 5 times 49 times 4. The thing that's nice is your calculator still has that key on it, or it has, if you're using my calculator, the combination option in the probability menu. So hit the math key, go over to probability, so PROB or PRB. Last lesson we used NPR, today we're using NCR. So option 3 on my calculator, so somewhere around 3. So I have 52 and then a C this time and 5. And I get 25 million, nope, I was right before, 2,598,960, if I can write a number here. So there are over 2 million, over 2.5 million different hands that you could get. So in how many of these hands are all 5 cards the same suit? Okay, this one's a little different because you have to consider how many suits there are. And so if you look at that list that we had, there are 4 suits, and we're going to have 1 suit out of those 4 because we want them to be the same. And then in that suit, there are 13 possible cards to draw, and we're picking 5 total. So we actually have to do this twice. So I'm going to go ahead and type in 4C1. So 4, hit my math key, probability, option 3, 1, gives me 4. Okay, so I have 4 options there. Can do that actually without a calculator. And then 13, C, option 3, 5, gives me 1287. So if I multiply those together, I get 5,148 possible hands that have 5 cards of all the same suit. Okay. So when we're finding the number of ways that an event can happen, you need to multiply them. When you find the number of ways that you have an or event, so the first one we had an and, now if we have an or, we would add them instead. So a restaurant serves omelets that can be ordered with any of the ingredients shown. So this goes back to that table that you have up here. So here's our table. So there's 1, 2, 3, 4, 5, 6. Whoops. So 6 vegetarian options and 4 meat options. So 6 vegetarian, 4 meat. Important to remember. Let's get back to where we were. Okay. So restaurant is serving the omelets. Suppose you want 2 vegetarian ingredients. So it doesn't matter which order I choose from those 6 vegetarian ingredients. I'm picking 2, so I'm going to use a combination. And then I have 4 possible meat options, and I'm choosing 1 meat ingredient. And then we're going to multiply those together, see how many combinations we can make. So 6 choose 2 is 15. 4 choose 1 is 4, so there's 60 possible types of omelets we can make. Okay, and then if we can afford at most 3 ingredients, and it doesn't matter what they are, we have 10 total because there's 6 vegetarian, 4 meat. So if we have 10 choose 3, we can afford that. We could afford 10 choose 2. We could afford 10 choose 1, but we can also afford 10 choosing none, and we can essentially have eggs. So we're going to calculate all of that out. And then this time, because it could be 3 or 2 or 1 or 0 ingredients, we're going to add those together because this is kind of like saying I can either order 3 ingredients, which gives me 120 options. I can order 2 ingredients, which gives me 45 options. I can order 1 ingredient, which is 10 options. Or I can order 0 ingredients, which, like I said, means you just have eggs. And because we're using an or, we're going to actually add those together to get 176 possible combinations. Okay, go ahead and try those next 2, and you can check those after that. In your practice, you're actually going to have to determine whether each situation is requiring permutations or combinations and then answering the question. So 8 members of a school marching band are auditioning for 3 drum major positions, and how many ways can students be chosen for drum majors? So we are going to actually use combinations because the order that they're chosen is not important at this point. Okay. So we have 8 total members. We don't care about the order, so order does not matter, and we're choosing 3. So we're just going to do 8C3, which gives us 56. Okay, and we're done. And then the next one, your school yearbook has an editor-in-chief and an assistant editor-in-chief. The staff yearbook has 15 students, and how many ways can students be chosen for those 2 positions? In these, the order does matter because those are 2 different positions. So this time we're going to go back to the last lesson. Of the 15, we're choosing 2, but the order matters. So now I'm going to use permutations. Okay, so I'm going to do 15, and we're choosing, remember to use the P1, okay, permutation key. Choosing 2, there are 210 possible options. Okay. Again, there's a couple guided practice problems there for you to try, and when you are finished, you can practice on Delta Math. Have a great day.